Inequalities. All right, well, to begin with, let's review pre-algebra knowledge of inequalities. Inequalities are the greater than symbol, the less than symbol, the greater than or equal to, and the less than or equal to. And the cool thing about inequalities is there isn't just one answer. Because if I said greater than 8, how many answers are there? Infinite answers, right? Anything that's greater than 8. Remember, if it was greater than or equal to, that changes it a little bit because it also includes the number 8. Right, so inequalities, right? Elementary school, you learned about them as alligators. The alligator or the Pac-Man ate the bigger number. Right? Inequality. So instead of an equal sign, we have these. Thinking way back, if you had a greater than or a less than symbol, when you graphed it, in pre-algebra, it was considered an open dot. So if you had x is greater than 8, if you were graphing that, I describe it to my pre-algebra students as it can't be 8 because there's no equal sign. So I draw a fence around the 8. You can't be 8. Could you be 8.01? Yes. But you can't be 8. So we draw an open dot and we shade above, because anything above 8 on the number line, anything up here is greater than 8. So that being said, if you had an equal to bar with it, do you remember what you put? You filled in the dot. So you put a closed dot. If it was y is less than or equal to -3, -3, -4, -2, right? We're going to fill in the dot at 3 because it could, anywhere that's shaded is an answer. So it could be -3. Or y is less than. So anything to the left on the number line. So we're using this knowledge, this idea base, and translating it into a linear, a graph, a line, like we've been doing with our bell work. All of those y equals mx plus b problems. So there are some pretty simple steps to follow. Let's say, step number 1. Maybe you need to do this, you probably won't very often. You need to solve the inequality for y. It needs to be y equals mx plus b form, because you're going to have to graph it. But instead of an equal sign, it's going to have one of these inequalities. So once you solve, maybe you can skip that, maybe it's already solved. You graph the linear, the line, inequality. So you find the intercept, you put a dot. Then from that dot, you count the slope. But there's a change. You use a solid line for greater than or equal to or less than or equal to. So if it has that equal bar, you connect the dots and make a line. Just like, see how we filled it in? You fill in all the spaces. You draw a line, fill it all the way in, because it's an equal to. You use a dotted line for greater than or less than. Kind of like how we drew a fence around the number up here. It can't be that number, so we have to draw it dotted. You can't come right up to it. Then, because it's an inequality, after you drew these dots, then you had to shade. So, you shade above the line if its y is greater. Because where does y on your graph get bigger? Y gets bigger going up, so you shade above the line. You shade below the line if its y is less than. Because y gets smaller going down. So if y is less than, you shade down. All right, these three graphs, it's going to be a tight fit. I'm going to open my book so I can... Maybe leave yourself like 3 spaces before you glue. Some of you will want to trim your graphs. If you trim your graph, please clean up your mess. Please make sure your graphs face the right way. All right, guys, are you almost done gluing? When you're done gluing, let's write down our equations. Let's do y is less than 3x plus 4. Y is greater than or equal to 8/5 x plus 4. And let's do a hard one. 3x minus 2y is greater than or equal to -3. So you've got your 3 graphs and you've got your 3 inequalities. Y is less than 3x plus 4. Y is greater than or equal to 8/5 x plus 4. And 3x minus 2y is greater than or equal to -3. So if you go back and you look at your rules, the first rule is to solve the inequality for y. So if I look at this one, is it solved for y? Is y alone? Yes, so I don't have to do that. Now I just move on to step 2, which is graph the linear inequality. So when I'm graphing this inequality, this linear, I start and I identify my slope and my intercept, right? Looking at that inequality, y is less than 3x plus 4. Where do I start my graph? At 4. What's my slope? 3/1. All right, so I look at my graph, and I'm going to start at 4. But I have a problem, don't I? What's my problem? Samantha? There's not enough space to go up 3 and over 1. So what do I do instead? Keegan? You do the opposite. Down 3 into the left 1. 1, 2, 3, backward 1. 1, 2, 3, backward 1. Do as many dots as you can. I got 4 on this graph. Yeah, so this time, every time it's a complete dot. Because it's not the rule of these type of dots. We use regular dots. Now we're going to either use a solid line, connect the dots, or use a dotted line. Which one are we going to use? Is it solid? Is it equal to? Here's how I remember it. If it's got the line underneath, I draw a line, a real line. If it's not, I dot it. So I'm going to dot it. So here's how I do that. I just go, instead of connecting the dots, I just make it a dotted line. Because it's not equal. I can't connect them. It's dotted. Now we need to talk about shading. Are we going to shade above because y is greater? Or are we going to shade below because y is less? Y is less, right? It doesn't eat the y. If it eats the y, I go up. So here I am, right here, at my y-intercept. Am I going to go up or am I going to go down? I'm going to go down. So see, I shade down here, right? But I'm going to fill in all of the space. So I also shade right here. What else is below the line? Is this below the line? Yeah. All of this is below the line because the line keeps going, right? And so anything below gets shaded in. And why do we shade all of this in? Anything over here works in this problem. Any ordered pair makes that inequality true. For example, 5, 1. That ordered pair is inside the line, correct? I mean, it's inside that shaded area. So if I substitute y is greater than or less than 3x plus 4, if I substitute this ordered pair, 5, 1, if I put those values in here, does it work? Let's test it. 1 is y. Y is less than 3 times 5 plus 4. 1 is less than 15 plus 4. Is that true? Yeah. Any ordered pair over here in this whole shaded region, not on the line, but in this whole shaded region, anything in here makes this a true statement. So let's try this one. I have to identify my M and B. What's my intercept? Where do I start this graph at? 4. And what's my slope? 8 over 5. All right, so this starts at 4, and I have the same problem I had last time. What's wrong? I can't go up 8 and over 5, so what do? Down 8 and backward 5. I do the opposite. I can only get 2 dots on this graph. But, am I going to connect them or am I going to dot it? Connect it because it's got the line underneath. So I connected my dots. And is y greater? So do I shade up where y gets bigger? Or do I shade down where y gets smaller? Up. Y is greater. So I shade up. So I shade everything on that side of the line. And again, anything in this shaded region, if I put the numbers in the equation or in the inequality, it would work. This time including anything on the line. Looking at that third problem, what's the deal? What's wrong? Y isn't alone. So I'm going to skip down here, and I'm going to get y alone. 3x minus 2y is greater than or equal to -3. You're going to have to think back, use a lot of pre-algebra in this, and algebra. What do you move first? Yep, you minus 3x. I have -2y is greater than or equal to -3x minus 3. Now what do? Divide by -2. Oops, I should have made this a 6. Go back and make this 6. All right, what's -3 divided by -2? Do you know? It's a decimal, so what can I put? Keep it a fraction. -3 over -2, x. They could both become positive. What's -6 divided by -2? Positive 3. Can you now graph that? Ladies and gentlemen, here's the trick. Do you remember this? When you divide by a negative number, you flip the sign. When you divide by a negative value, you flip the sign. What's the intercept? What's the m equal? The m is 3 over 2, and the b is positive 3, correct? So start at positive 3, and I go up 3 and over 2, but I want as many dots as I can. So what do you do now? Down 3, backward 2, down 3, backward 2, down 3, backward 2. Is this a dotted or a connected line? Connected, because it's got the line with it, right? Is y bigger? Do I shade above? Or is y smaller? Do I shade below? Y is smaller, right? So I shade below the line. What if my slope looked like this? Are both of those numbers negative? Are both of those values negative? Does that mean I go down 1 and backward 3? Corbin says no. Corbin, how do you assign the negative in that? You give it to one of the numbers. Don't do both negative, because if both are negative, what happens? It makes it positive.